Okay, so hello everyone. Thank you for coming to a new meetup. I see new faces, so can you please raise your hand if it's the first time you come to one of our meetups? It's the first time?
My first time.
Okay, welcome. So we always like to know new people. We are two groups, Madrid Ruby user group and Madrid Java user group. We've been doing meetups together now 3 years. So there are all our contact information. We record all the videos we put in our YouTube channels that we should put here, the YouTube links. And yeah, you have all information. If you want to give a talk here, just ping us and we can make it happen. It's pretty simple. We're a small group, so you will feel like home and family. So thank you for Blues for being our host today. At the end, don't leave. We will have some pizzas and something to drink, so we can talk a little bit about the talk. And now I will leave David to give something about the Blues.
Yeah, just so to really appreciate you to come again to our house, and we are really happy to support all the Java and Ruby community. And yeah, so we are just if you don't know us, we are the leader in e-commerce for pets in Europe. And also we have a lot of technologies in place. We are using not only JVM, but also we are using Python. We are using Scala also in other places. So yeah, happy to have you here. And yeah, also let's hope that the next time you also select us to host your meetup.
Yeah. Yeah. Remember, there are no stupid questions. The only stupid question is the one that you don't ask, because you go home and then you start thinking, okay, I should have asked that. So, if you have a question, do it at the end or whenever you want. Oh, and that's it. We have this session. I will leave Howie.
Oh yes.
Howie to introduce himself, and that's it. Let's see what we have for today. Thank you.
Okay. I'm just going to record this in QuickTime as well, just in case you want the recording later. Screen recording. Okay, so hello everyone. My name is Howie, and this presentation is about engineering a better Java build tool experience. So the motivation for this talk is that although Java is known to be very performant, very easy to use, and have very good IDE support, Java build tools don't always live up to the expectations. They aren't always snappy and fast. They aren't always easy to use and extend. And IDEs don't always work with your build tools as well as they do with your application code. So this talk will explore what are the limitations of the existing Java build tools, why is it a challenging space to work in. It'll explore one of my personal open source projects, which kind of explores what we could do with the Java build tool, and talk about some of the ideas that allow it to be better than what's out there today. So about myself, I learned Java 21 years ago now in school. Back then was Java 4, you didn't have generics, you cast everything, you took out of the linked list or array list before I could use it. I've been doing open source Zero projects since 2012. My last job was at Databricks, which is a Scala shop, so a lot of the projects are in Scala, running on the JVM, but also some Java, bytecode, manipulation, and other things. So my professional work is specialized around developer tools. So dev environments, test environments, CI environments, build systems, and so on. So things like Bazel, Jenkins, Circle CI, GitHub Actions, or proprietary versions, and all that. So this talk has 4 sections. First, we'll look at what are the challenges with existing Java build tools and what are the both for users as well as for build tool designers. We look at Nil, which is a build tool that's one of my open source projects, not as nearly as popular as Maven or Gradle, but it's usable, and we'll see what it is. We'll see what concrete improvements you can demonstrate that makes it interesting as a build tool, and look at one of the interesting ideas, which is these object-oriented builds that Nil kind of focuses on. So first, can Java build tools be better? So these are the 3 ideas, right? That people complain about. So everyone uses a Java build tool. No one runs Java C from the command line because you pass in a huge class path, you go download your Java from somewhere. You can't do that. But when you use the build tool, often it's a bit slow, it's a bit hard to use, it's a bit funky in the IDE. So these are the problems that everyone seems to face in the Java ecosystem. So first, looking at performance, people don't realize how fast Java compiles or can compile. So everyone uses a build tool, so you have limited by the build tool. For example, Netty, which is the open source async networking framework, 500,000 lines of code takes about 50 seconds to compile on my machine in 10 cores. So I'm just going to show you this now. I'm going to copy paste this command into my terminal, go to the Netty example. We're not going to wait for it, I'll just kick it off here. Install does a bunch of other things other than compilation, but if you really limit it to like one module and just compiling that one module, skipping tests, skipping linters and so on, it's still about the same speed. It's like a few thousand lines a second. So 29,000 lines in Netty Common takes about 4.5 seconds to compile using Maven. And whether this is good or bad is hard to say in isolation, but if compared to using Java C without Maven, you'll see it takes only 1.5 seconds. And you see Java C, of course, there's this huge class path you're passing. You can't do this manually, it's a pain in the neck. But it's 3 times faster than Maven, and this is the slowest you can ever make Java C run. Who knows why? Why is this the worst way you can make run Java C in terms of the performance? Right from the command line.
Que algú s'ha acabat de venir a command? Ha preguntat?
Yeah, it's because Java C is a Java application, and Java applications start up slowly and only get performant later, right? So that you all know that's how Java applications work. Java C behaves like that, and despite that, it is still 3 times faster than Maven. So if you actually look at how fast Java C can be, if you run it in memory, so I have this bench.java script that just has a while loop that runs Java C in the same process over and over to see how fast it can get. It actually runs 5 times faster than running code, which is what you expect, right? Like running a Java program from command line is very slow, but if you let it warm up, it gets very fast. In this case, it's about 5x faster. So you can see this live. So earlier I kicked off clean compile over 10x parallelism on my laptop. I have 10 cores. It takes 50 seconds for the whole Maven Netty code base. If I compile a single module, again, clean compiling just that single module. So I'm not timing the clean, just the compile part. 174 source files, takes about 4.7 seconds, about what we saw on the benchmark on the slide. If we use Java C in this very long class path, which I just copy paste, you see it's much faster, it takes 1.7 seconds instead of 4.6. And there's this bench.java script, which I'm just going to show you now. So bench.java, where's my Netty code base? Bench.java is just like a small Java application you can run directly using Java nowadays. You don't need to run Java C separately. And it just is a while loop that uses the built-in Java compiler API over and over in memory. And the point is just to let it get warm up so you can see what the real performance is like when it's actually running.
You are using the API of SDK
Yes.
library.
Yes. So this is built into every project. I think it's javax.tools.java
okay.
compiler. Every JDK has it, even if you don't use it much. So if you run this, you'll see it starts off a bit slow and gets faster and faster and faster and faster because that's what JVM does. If I can't interrupt at any point, and I guess find it. You'll see that it's now compiling 29,000 lines in 267 milliseconds at 110,000. So yeah, so this is like compilation's not everything, but this is just an indication of how much overhead the build tools add over like the Java tooling. Java actually is very fast and very performant. Just a build tool often just wraps it and makes it a bit clunky. So in theory, we should be able to compile the whole of Netty in 5 seconds on 1 core instead of 50 seconds on 10 cores. But because of the build tool, we're not able to get that performance out of it. So the next thing we're going to look at is ID support. This is also an area where Java is known to be very good. So if I open up a different code base, I'm going to use the, let's see, is it this one or the other one? Yeah, so this is a Mockito code base. It's a popular unit testing framework. It's built using Groovy and Gradle. So this is a Gradle built for one of the Mockito submodules. And you'll see there is ID support with like syntax highlighting and stuff. You can jump to some things, but you can't jump to others. So like I can't jump here, I can't jump here. I can jump to JVM args, but you can't just get this getter and setter, you don't get any value. And this I haven't downloaded the sources yet, but if you download the sources, you can't just get the same thing with Scala doc, with Java doc. But if you look at any part of the application code, like let's say I open up a random file, it's totally at random. I can literally jump to anything in this file and it brings me somewhere useful. Like I never just get these like getter and setter that tells me nothing. It always brings me somewhere useful. I don't know what this is, I jump to it. Don't know what this is, I jump to it. This is what people expect from Java programs in IDE. But in your build file, you jump and you just get like nothing. So I mean, I think the real problem with this is that these build files in Gradle are built around these like global mutable variables. So you're like appending to this global mutable variable. Just because you wrap in a getter or setter doesn't make it any less global or any less mutable. So if you use global mutable variables in your application code, you have the same problem, and that's why people don't use global mutable variables if they can avoid it. But then like in your build script, because it's built on global mutable variables, and like your IDE just can't figure it out, and neither can your poor engineers. So that's the IDE support angle, and I showed you the Groovy language for Gradle, but the Kotlin syntax actually has the same problem, despite Kotlin having very good IDE support and using application code bases. So the last thing I'm going to look at is programmability. So like usually build tools, if you can just use the defaults, that's the best, but inevitably you need to extend it. Either you need to go find some plugin to do something you need, or you need to make it configure the build tool yourself because you're doing something unusual and special. So for example, the Netty code base needed to compile C code as part of the build. And the the Mockito code base needed to do some class file mangling as part of its build in Gradle. So everyone has to do something, and you don't want to do it, but you have to. And as an example, like a strawman example requirement, I'm just going to say I want to save the project line count as a line count txt file, just to give us some like benchmarks to see how it looks like to extend the various build tools. So to do this using Maven is not difficult, and you get a snippet that looks something like this. Most likely, like you use the exec Maven plugin, you shell out to bash and run make dir and find and blank word count and xargs, and it works. But it's surprisingly tricky. Like you'd expect such a simple requirement to be a 30-second task with 0 error rate because it's so simple. Even like a student should be able to do it. But a student won't be able to get this right without a bunch of fiddling and documentation and ChatGPT or Google or whatever. And even there are alternative ways to do it, and all the alternative ways are not not impossible, not actually that difficult, but not easy. Like you want to have a custom Maven plugin, can be done, but it'll take some fiddling and take some learning and Googling, and you eventually get it right. But it's given how simple this is, you expect it to be much easier. Gradle has a different set of trade-offs. So this example is using the Gradle Kotlin DSL rather than Groovy. And Kotlin is cross-platform. Don't need to worry about Windows because it runs on JVM. Don't need to worry about escaping because you're not writing bash, wrap and XML. But it has some other trade-offs, like you need to register all these task input-output dependencies, and there's quite high likelihood you'll get something wrong. So like in this case, there's actually a bug here that will make this build task run, slow your build down non-deterministically sometimes. And I bet none of you can spot it, even though you're all experienced JVM Java developers. Like, where's the bug here? So sometimes the build will just get slower because of this custom task. And it's like the simplest save the project line count as a resource file custom task. So give you like another 20 seconds, see if you can spot where the bug is. It's code review, and some junior engineers in this deal. You merge it or not. So the bug is actually here. So we are declaring a dependency on source main, but we actually only want source main Java. That means that anyone who touches the source main resource file, source main template, source main any config is going to make this line count task unnecessarily recompute. And for this case, it's trivial, probably doesn't matter, but you can imagine any bigger task, it'll get even harder to spot the bug because the configuration will be more, and the task maybe take some time and be slow. So this kind of bug is why your build gets either slow over time because these bugs slip into master and you can't catch them in code review and God knows why. Or your build gets flaky if you make the bug the other way and depend on too few sources rather than too many. In that case, you won't execute when you should, and your build may become a bit non-deterministic and problematic. So that's how builds become slow and flaky. And it's not because people aren't doing their job, it's because it really is quite hard to find bugs in this kind of build config that Gradle or Maven or other build tools ask you to write. So that's the three things that people complain about for build tools typically. And it's worth asking, like, why are build tools so hard? Like, why can't people just fix it and make a really simple build tool? And the answer is that build tools actually need to do a lot of things that people often don't think about but are there. So like, you don't care about what task depends on what. You don't care about how a task caches, but the build tool needs to care. Build tool needs to cache things, and build tool needs to parallelize things. The build tool needs to have some extension syntax in Groovy or Kotlin or XML. So even though you don't think about this, the build tool is actually quite a complicated piece of software, and If anyone tries to make an API that models all these things, it can get quite complicated quite easily. So that's why build tools are not so easy to improve. So that's the baseline, but can Java build tools better? Maybe, like, yeah, there's room to improve, but it's not an easy field to work in. So next we'll talk about Mill, which is one of my open source projects, which is a build tool. So Mill is an open source JVM build tool that is kind of exploring the solution space of build tools to see, like, are there better ways to do it that are just radically different from how Maven or Gradle work. And the current number, top line number, is that it actually is like many times faster than Maven or Gradle to compile the same code, which I found quite surprising, using the same Java compiler. And so it's not a big project. There's like a few maintainers and contributors. It's quite widely used in the Scala community, but not so much in Java. There's only a few projects I'm aware of that use it in Java community, even though it is usable. A basic Mill build looks something like this. So Mill uses Scala syntax rather than Kotlin, but hopefully you can come screen edit and guess what it means. So I have an object that extends a class. I have some method definitions, like IDDeps has some groovy Gradle-like dependency strings, and there's a nested test suite, which is a Java test suite with some JUnit support. So you can run foo.compile, foo.run, foo.test, foo.assembly, run the assembly, all your boring build tool stuff. This is a slightly more involved example that is a to-do MVC Spring Boot application, which I can show you live. So here it is, good Spring Boot. So this is a lot more complicated than Hello World. It has all the Spring Boot dependencies, JAXB, WebJars. It has H2 for in-memory testing, test containers, Postgres for integration testing. I can run like Mill, Mill tests from the command line. I can run, you can see it runs Spring Boot and then shuts it down when it's done. I can run the test in the IDE. Hopefully my IntelliJ integration works. Yes. I can do like nil -- watch test.run background, which will run the server interactively. And then I can go at localhost 8087 to see my application. This is just normal Java Spring Boot code. I won't show you the code for the application. And then since I'm using -- watch, I can go to the resource folder and like make changes. Like instead of to-dos, I can say like to-dos hello. And then it'll reload and I can see the change here. So now if I run the test again in the ID, it should fail because it's asserting on the to-dos header being there and now it's no longer there. So again, nothing that you can't do with other build tools, just showing that this stuff works, like IntelliJ and command line and the frameworks and so on. So people will often ask, like, what does it, if that works, what else works? And this is like a kind of short laundry list of what works. So all your standard open source tools, none of your proprietary tools will work because those are things you made purposely for Maven or Gradle, so there won't be any Mill equivalent. But for open source things like checkstyle or Gradle native, because it's open source, we have integrated it ahead of time, so people don't need to do it themselves. So that's a quick tour of the Mill build tool, and so far what I've shown is basically the same as any other build tool does, so that's not so interesting. So what's interesting, I think, is where Mill is able to show like an improvement over the other build tools despite being a much newer and less mature project. So the improvements are in the same buckets we saw earlier: performance, ID support, and programmability. So for performance, we use the Netty code base again as a benchmark, and Netty is not a small project. It's like 50 submodules, and we ported the build from Mill just manually. It took about 1 or 2 days. And it's complete enough. You could run all the tests in Mill and all the tests pass. So it's actually quite a complete port. So if I go to my Netty Mill build, sorry, let me go there now. If I do Mill clean, sorry, /mill clean, if I do a clean compile, it should take a lot less than 50 seconds. The first time it'll still be a bit slow because Mill runs on the JVM. As you saw, it uses Scala syntax, and Scala runs on JVM. So first time it'll be a bit slow, may take more than a bit of time, but hopefully it will speed up. So first time we run a clean compile, it took 16 seconds. Second time you run a clean compile, Mill keeps the background daemon running like Gradle or Bazel do, so it gets faster kind of on its own. So the second time took about 9 to 10 seconds. So that's quite a big speed up over the 50 seconds we saw for Maven. And if you do like other benchmarks like incremental compiles or cleaning a single module or sequence turning off parallelism and running on single thread, it all shows quite significant speed ups. Like for example, if I touch a single module in the Netty code base, let me see, do like, so if let's say I change one file in Netty common, where's common? So change Netty common, Java. I'm just gonna like add like hello here. You run mil clean compile. It notices that one Java file change and compiles in about 1 second. Whereas if you run Maven compile, without clean, just Maven compile, you'll see that even though nothing changed, it takes quite a while to notice that nothing changed. And it has to compile all the files in those modules and isn't quite so smart about incrementally skipping the ones that it doesn't need to recompile. So that's where you see these benchmarks down here, where a single module recompiled in mil is very, very fast. But Maven doesn't have that. Gradle has some of that.
Do you have some tests like this, but with a Gradle build?
Yes.
A big project, because Maven it's not very good for incremental compilation, but Gradle is.
Yes, so that's the next one.
Okay.
So the next slide is we use a Mockito code base, the same one earlier as a proof of concept. So this is about 20 subfolders, 20 subprojects, not as big as Netty, but still pretty big. And again, we ported it to mil. So yeah, Gradle is much better incremental compilation. You see it like takes about 1 second incrementally compile. So mil and Gradle both have incremental compilation. Mil just is a bit less overhead. And similarly for parallelism, Gradle also keeps a background daemon that lets the JVM warm up, but somehow it just still has more overhead for compiling the same code. Not as much as Maven, about 2x faster relatively, but still much more than mil. And mil is still much slower than it should be compared to Java C. Like Java C should make it like basically instant. But mil still takes quite a lot of time on many cores to compile everything. So that's like the performance angle for compilation. Compilation is not the only thing that matters. There's a bunch of other things that are nice. Like mil has this selective test execution where you can take a snapshot on main, take a snapshot on your pull request branch, and ask mil what changed, what test do I need to run to validate this pull request. And it will like take your git diff and then it'll do a breadth-first search down the module dependency graph. So every build tool has its module dependency graph, but mil makes it easy for you to ask to run the things downstream of the code changes, which is often what you want in a big code base. Mil can make assembly jars much faster when you're iterating on them because it can incrementally update an assembly jar. So the first time you make an assembly jar, all build tools are quite slow for this like 200 megabytes spark submit assembly. But if you add one file and rebuild the assembly, mil can do it in 1 second just because assembly jars are just zips, and zips make it very easy for you to take out individual files and put in new files. And so that's what mil does using Java and IO zip file system. For some reason, other build tools don't. The last thing that's interesting is this Chrome profile. So every command you run using mil, the Maven clean compile failed. Okay, never mind. Probably need a clean install. So every Chrome browser has this profile visualizer. Has anyone here used this? So if you have anything you want to visualize a parallel profile, you generate JSON in a particular format that the Chrome team has documented at Google. You can just dump it into Chrome and see it'll tell you where all your time is going. So for example, if I do another clean compile with mil, just so it's visible, and I'm wondering like where's the 10 seconds going? You can kind of see a bit in the command line, not really sure. It generates this mil Chrome profile.json file. Yeah, and you can't read it much manually, but it's a standard format that Chrome understands. And from this file, you can just see where did my time go. Like took 9 seconds. Well, here's your 9 seconds. Like at first it was doing a bunch of stuff. You can click on each thing to see like you're doing resolving the dependencies. Then it got bottlenecked and common compile. Eventually other things kicked off compilation. Then it got bottlenecked on microbench compile. So this is very handy because if you're often wondering what your build tool is doing, and this just tells you very easily. And unlike other build tools, you don't need to go find a plugin for Maven, or you don't need to sign up for Gradle Enterprise and do a build scan server, AWS account, and upload your build scans. You just like open your Chrome browser to this URL that you already have, and you can just dump the JSON file in, and it just tells you like where did the last 10 seconds of your life go. So that's the performance angle with mil. Like it's a bunch faster, which is quite nice. Also, there's some nice features that the other build tools don't have or don't have so easily to use. Next is the ID support angle, which I think is very interesting. So both mil and Gradle and Maven, they all have ID support. but the ID support really differs. So if I compare the same, let me see, error prone. Okay, here we are. If I compare the same like config for the error prone submodule of Mockito code base, on the left is the Gradle config, on the right is the mill config. So you'll notice that it's almost exactly the same because this module needs these flags to run. So Maven, Gradle, mill doesn't really matter. You need to pass in the same flags. And they both have some syntax highlighting ID support. Even mill, some parts get a bit wrong, IntelliJ gets confused. But what's interesting is for Gradle, when you jump to something, you often get these stubs because you're using global variables. Mill is based on object-oriented override. So you notice this override icon in the gutter. This is a standard IntelliJ override thing. So this is a Scala syntax for a method, and this overrides the previous fork args. And IntelliJ knows that and can tell you where it came from. For example, it overrode this one, and this one. And you can jump to the override, overread the method. Again, this is Scala syntax. We can guess what this value is. It's a task that returns a sequence which is empty. That's an empty sequence of strings. And you can just navigate this method call graph as if you're an application. So fork args gets used in runner, which is another method. Runner gets used in run background task. This run fork task. Run fork task gets used in run. So this is interesting because when everything is going right, you don't need to debug your build. Or the documentation is up to date, tells you exactly what you need to do, that's fine. But when things go wrong, documentation doesn't tell you what you need to do, or documentation is out of date, or using some third-party plugin that isn't documented well, or some internal plugin, then being able to navigate your build and see not just what the documentation of this field is, but exactly how it gets passed through my build pipeline to end up affecting the thing I care about. So I set fork args because I care about the run, how it affects my running, and now I can see how fork args gets passed through the build ends up affecting my run task. And you can go the other way too. For example, let's say I don't want to find the main class if I don't know how it's computed. Ideally, there's docs. Maybe you didn't see a docs, or can't find the docs, or they're not clear. But in Mill, I can just jump to it. There's no documentation, but I have the implementation. Again, I can jump to this. No documentation again, but there's implementation. You can see it's calling the main class. That's either you configure explicitly or it calls all local main classes. You don't know what this is, you can jump to it. Like here. And you see all local main classes uses class graph, which is another open source project to do a class path scanning to try and discover the main classes that are on your class path. So what's interesting about this Mill ID experience is it's exactly what you get in your application code in Java and Kotlin and Scala and whatever, and C# or nowadays Python with types and TypeScript with types. And that's because Mill is based upon method definitions and overrides, method calls rather than global variables. So whereas in Groovy, like any other global variable heavy code based ID can't really help you, in Mill, the ID really can show you how does the build work. And again, when things are going well, you don't care, but when things go badly, which is when you typically look at the build, this is something that gives you a good escape hatch to try to figure out what's going on and how you can fix it. So that's ID support angle, and this is a demo we saw live. So the last thing we're going to look at is the idea of programmability, how easy it is to program your build. So the first thing to talk about for Mill is that it has lots of stuff built in, so you don't need to program it yourself or find plugins quite so early in the project lifecycle. Like all the standard linters and formatters and deployment models and packaging things are all built in. So the non-standard ones you still need to configure yourself or find a plugin, but the standard ones are built in, so you can just create an assembly or create a Gradle native image without first having to do a grand tour of the Java open source GitHub ecosystem. But eventually, when you do need to extend it, where the difference comes is that where most build tools require you to find the plugin or write the plugin, only lets you just write code to do stuff. And we'll also see what that means live. So I haven't opened it yet. Let me open up the correct example, custom Java. So make this bigger, clean up my terminal. So over here is the Mill build for the most simple Java code base. Is the object, which is a Java module with no config, because this is just a class, and the class has all the default methods or default values for things like so where the source folder, how does compile work, all those have the defaults. So if you don't want to configure anything, this is all you need to do. You just say an object for extends Java, and I can say mill foo.compile in my terminal and see it compiling that code. So let's say I wanted to do the requirement I had earlier, which is save the line count of the module as a text file. How do I do that using Mail? So in Mail, as I mentioned, your build tool is configured using methods and overrides. So in Mail, you define method, you use a Scala syntax to def, similar to Groovy. And then you can do like line count equals task. This task block looks kind of like Groovy or Gradle or Kotlin. And I can call other methods like foo.sources or all source files. And if you're not sure which method you want to call, you can like ask ID and it tells you together with the Scala doc or Java doc here. So in this case, I want all source files. And I want to say, I take it, I map it, each file goes to the file path. I read the lines using the standard OS file system library, and I sum them up. So this is just the map filter sum, like Java streams, just without the .stream and .collect. And that's all I need to do to define a custom task that counts lines. So I can do mil show foo.line_count. First time you run it might be a bit slow, it needs to recompile the config code. So there are 17 lines of code in this small example code base. I can do mil inspect foo.line_count. You can see it gets a file name, line number, captures the Java doc for you, captures the dependencies for you automatically, so you don't need to have a separate registration call. And that's all you're done. You have a line count task for you that you can work with. So we haven't integrated it into the resources yet. So to do that, you override the resource task. So I mentioned earlier that the Java module already has resources, sources, all and the way you reconfigure a Java class is by overriding it. So in Mail, you say override dev resources. Again, you can ask the IDE to see the documentation if you're not sure. And I can say super.resources, and I can write using the built-in file system library to this destination folder, which I'll touch on in a moment, the line count as a string. And I'm going to append this as a path reference to the task destination folder. So what's this destination folder? So in Mail, every task gets its own folder to put stuff in. So if I do Mail show foo.resources now, you'll see that, let me make this a bit wider. You'll see that apart from the normal resource folder, which is now called super.resources since we overrode it, Mail also has this out foo resources.dest. Out is like the output folder for the build tool, which is this task.dest folder you see on the right. So every task gets its own destination folder put things, and they never collide with each other because they're based on the name of the module and the name of the task. So this is very handy because the problem with the file system is that you don't know who's writing to where and who's deleting from where and who's having race conditions writing to disk to the same paths. And with Mail, because every task gets its own place to put things, it keeps things a lot neater and makes it easier for both humans and the build tool to work with. Yeah, and this is all we need to do to integrate the line count. I can do Mail foo.run. And our small Java application is able to use class load to get resource as stream to load it from the class path, resource path, and print it out down here. So let's take this one step further. Let's say I want to use a third-party library as part of my build. So this is very common. Like in other build tools, you have to find a plugin for that library. Let's say I want to use Timeleaf in my build. So Mail doesn't come with Timeleaf built in. It's not a web framework. You try and use Timeleaf in your build, it'll yell at you, and IDE will yell at you as well. But what you can do is you can say, because it doesn't know what this is, you can say import using this $ID syntax or .timeleaf : Timeleaf : the version. This is the same Gradle style version string. I think or something like this. And now, if I run it from the command line, you'll see no longer using a compile error. And if I reload it in my IDE, you'll see now it's able to resolve Timeleaf and load it into my libraries tab. So now I can use Timeleaf and say I can import the context, I can import the template engine. You can define a new task using Timeleaf, like HTML snippet. I can say val context equals new context. I can say context.set variable line count to line count as a string, and I can say new template engine dot render or dot process. I'm just going to copy the template string from the slides because it's a bit long. So copy this template string over. So I process the template string and I pass in my context. So now if I can do show foo.html snippet, and you can see the output of my pre-rendered HTML at build time. I can open up my out folder foo/html snippet.json. So which you can see it has a cache of the data along with some metadata, so it knows when to invalidate things, it hashes the inputs and stuff. And now if I replace my resources with previously writing the line count to instead write the HTML snippet, I can do mil foo.run, and I'm able to pre-render my HTML at build time and use it in my runtime application code using a third-party library, using my own custom logic. And what's interesting here is that there's no plugins to be seen. So I didn't need to go find the mil timely plugin, there isn't one. I didn't need to find a mil exec plugin, mil line count plugin. You can just write methods that do things, use libraries that you already know in from production use case, and it works exactly as you work in any other code base. The syntax is Scala, so it's a bit different from Java. You don't need semicolons and use that to define methods, but otherwise, hopefully, it's relatively understandable what's happening here. So I have a line count method that calls all source files, HTML snippet method that calls line count, and I override resources for HTML snippet, and then it will take care of the caching and other things for you. So you just define the methods that call each other. So back to the slides. So that's the interesting thing about mil, I think. Like the extension model makes it very easy to program. So if you compare like the mil extension line count resource extension versus the Maven one, you'll see that although Maven is supposed to be declarative, sometimes you do need imperative code, and you do end up having like exec to or using bean shell or using ant run or something to just put some imperative code because you need it. And just because you wrap in XML doesn't make it declarative. And so you have the same logic in both, and the logic for Maven actually isn't that complicated. It's just the boilerplate around it is very easy to get wrong. And even though it's in XML, it's still bash code, and the bash code doesn't have type checking, doesn't have ID support, doesn't have testing, doesn't have all the nice things that you'd expect. Whereas the mil code running in IntelliJ using Scala syntax does. Compared to the Gradle code, again, you'll see that the business logic, so to speak, or the build logic that we care about is actually very similar. The Gradle code could probably be made a bit more concise if we use a different task, so we don't need to do the recursive walk ourselves. But otherwise, like the recursive walk is actually not complicated, and it's not something that people tend to get wrong. Like I bet when I ask you code, you use this code, you're probably all looking at this recursive file system traversal. But what people tend to get wrong is all this other stuff out here, where you're just kind of registering the task and trying to wire up your build logic into the wider build graph framework. And this is where we screw up the dependency registration, or we screw up the depends on call, or we screw up do last versus do first, or something like that. So mil doesn't make the build logic go away, but mil lets you kind of mil automates all the other stuff that build tools like Gradle or Maven make you do. So you don't need to worry about phases or who's running first, who's running last. You just call the methods, and the ordering will be taken care of based on what method calls what other method in what order. And so customizing mil, even though you do have the right kind of code, is much less dangerous than writing code in, for example, Gradle, even with the new Kotlin type check DSL. So that's the programmability angle where I think mil is pretty interesting. So the last thing we're going to look at is this idea of object-oriented builds. So like mil has a lot of neat features, but a lot of the neat features can easily be copied. Like Maven, like mil has a long-lived daemon, but Gradle has a long-lived daemon, and Maven with Maven D, when that eventually lands, will also have a long-lived daemon. But one thing that's probably fundamental to mil is this idea of object-oriented builds. So like I mentioned earlier, build tools are quite complicated systems, and one of the things every build tool needs you to do is to define a templated, customizable graph computation. So if you look at what like an example 3 module build graph on the bottom here, foo.bar, which is called by, it depends used by foo, which is used by Quux. Each have their own source files, each have their own compile step, each have their own main class and the class path and assembly jars tasks. Foo.bar is used, class path is used by foo class path, used by Quux class path. So it's quite tricky. You have this quite complicated graph. It's templated because the modules look almost the same. It's customized, needs to be customizable because the modules aren't the same. Like foo.bar has no upstream dependency of class path, but foo does. Some of them have special command line arguments or special environment variables. It needs to be a graph because you need some way to parallelize and schedule the work to do. And you actually need to do the work, which you need to have some kind of computation. So if you kind of imagine what an API for a templated customizable graph computation looks like, try and sketch one up in Java, it can get very complicated. And even if you, as a build maintainer, don't need to do this because some plugin author is doing it for you, the plugin author can also screw it up. So if it's very complicated, your plugins will have bugs, your plugins will be slow, your plugins will be flaky, and not for your fault, it's because the plugin author is a human too, and they couldn't figure out how to work with the customizable templated graph computation when doing their Gradle plugin or doing their Maven plugin. Earlier we saw Gradle with all the depends on calls and stuff. It's constructing this graph so that the Gradle can execute it later. So Mill also needs to do this complicated stuff. But Mill uses a concept which is object-oriented programming, which you all already know. And this is quite interesting. So like when I say object foo extends Java module, it's literally a JVM object extending a class. You extend a class, but you get these methods. The methods call each other, and then this forms a call graph. For example, simplified, sources is called by compile, called by class path. Together with resources, it gets called by assembly, because assembly needs the class files and resources to put into the assembly jar. So when I add a new task, like I say def line count for it, and a new method that calls all source files, or I say override def resources, and it calls super resources, and it calls line count, you already know what this means in terms of changing the call graph, because you learned override and super and method calls like 20 years ago in school. And it maybe wasn't easy to learn back then, but now that you've learned it, it works exactly the same here. You know exactly how this slices these two new methods into the call graph. Even things like super, which are quite subtle, it works exactly as you would expect. And once we have this graph, Mill can then do the normal graph things, like I can run the blue task with compile and the red task with line count in parallel because they don't depend on each other. Mill knows that the green task assembly needs to wait for both to finish because it depends on both of them. Mill knows every task has a method has a name like foo.linecount, foo.compile, foo.resources. So Mill can automatically give you a command line string to run. So Mill, you literally say foo.linecount from the command line to run it, or foo.compile. And Mill can also automatically give you places on this to put your stuff that's unique to that task. Like line count of JSON is unique to line count to put its metadata return value, and foo.compile, foo/compile.dest is the place where all the compile output should go. And this is unique, so when I have assembly task, it automatically goes in a separate folder and separate file, and it will never collide. Lastly, when you Mill can do incremental recomputation for you. So you touch the resource folder, which is now super resources because you overrode it. Mill has its graph, so Mill just does a breadth first search, knows that resources needs to recompute, assembly needs to recompute. Mill knows that compile and line count do not need to recompute because they're not as part of the breadth first traversal. And Mill also knows that assembly can be deleted at this path, so it knows exactly where to delete the old value because it follows the convention. And for compile and line count, Mill knows exactly where on this to fetch the old values because again it follows the very strict convention. And what Mill can do all this for you without you doing any code at all, really, just dependency tracking or parallelism or caching and all that. So you look at this build logic on the left, you don't see any depends on calls or file inputs, file output registration, you don't see any parallelism like threads or futures or locks or executors or semaphores, you don't see any cache key computation or cache invalidation logic. You basically write the kind of core build logic here, and Mill just does all the rest for you because once we restrict the build logic to only write to the output folder and only read from the input tasks, Mill can be very confident about where to delete stuff and where to write stuff and where to schedule things. So if we go back to this big laundry list of what build tools need to do and why it's complicated, Mill also needs to do all these things, but Mill can leverage these concepts you already know to answer these questions. So that who depends on what depends on the call graph. Did you call them? Well, now you depend on them. Who needs to run what order? Well, you take the call graph and do a topological sort, and then that's the order you run it. And how do you define your own custom task? You define a method. How do you pass data between tasks? You return the data as a return value of the task. So the method call graph gets us a lot of the way here. And the things that aren't answered by a method call graph are often answered by the kind of object-oriented nature of the build. So the idea of foo.compile as a command line command to run the task, or the foo/compile.dest as a file system path for output files. The idea that if you have multiple modules that look the same, you just define a class and instantiate the class 3 times. And if one module is some special snowflake with a different compile task, well, you just override the compile task and do your own special thing, and maybe use super if necessary. So all of these concepts are not trivial, and even the answers here on the left and the right are not trivial, But because these are answers you already learned as part of learning object-oriented programming, you don't need to learn it all over again like you would for Maven or Gradle or Base or other build tools. You can just reuse your object-oriented concepts like objects, methods, classes, and overrides, and that's all you need to know to understand this quite complex job of configuring a build tool. So for the object-oriented builds, to sum this up, like mill builds are methods calling methods, objects inheriting from classes. So extends, overrides, super, method calls, they all work as you expect. And because they all work as you expect, they also work in the way IntelliJ expects, and that's why IntelliJ can navigate the build even though there's no special IntelliJ mill plugin. Like, it just treats it like any other object-oriented code base, including things like resolving superclasses and inheritance hierarchies and method calls and all that. And mill handles all the other stuff for you, like caching, parallelism, and validation. So it means that performance is good because you won't screw it up and forget to cache something. You don't need to clean because you won't screw it up and cache things too much, which often happens in other builds. And it makes life easier for everyone. Like, as a build author, you don't need to worry about this. As a plugin author, you don't need to worry about this. So it's quite easy to write plugins for mill since you don't need to care about all this graph stuff. And even as the mill maintainers like me, we have time to do things like incremental assembly jobs and other fun projects rather than fighting the build graph configuration, to make a correct incremental build graph. So that's object-oriented builds, which I think is a very interesting idea that's very different from how most other build tools do it. Like, other build tools have daemons, other build tools have caching and parallelism. I'm not aware of any other build tool that has this cool object-oriented class method build structure. So here's the last slide. I guess to sum it up, there's probably two main takeaways here. One is that there's a lot of this low-hanging fruit that other build tools haven't picked, like having a long-lived daemon in Maven, having incremental compiles in Maven, automatically tracking dependencies in Gradle so you don't need to go register them yourself. The mill kind of proves it out that, yeah, you can do it and it's not that hard, and it does feel great when you have these nice quality of life features. The other idea here is that I think mill is really quite cool. So if you are tired of waiting 5 years for Maven or Gradle to get these nice new features, you can try out mill. I think there's a lot of interesting ideas, especially these object-oriented builds, and not only are they interesting ideas, but they translate into real improvements. Like, the better performance is because we can do caching better. The better ID support is because we have this object-oriented ideas that ID understands. And these are really things that are unique to mill that other build tools don't have. So if you want to try a different flavor of build tools, mill is definitely worth a try. I can't promise you everything will work. It's still pretty experimental. But the things I showed you here do work, and hopefully more things will work over time. Yeah, and the website below and the GitHub and documentation page has examples, and you can download examples and run them. You download the zip, you can unpack and run. So if you want to try it out, it's very easy. Yeah, and I guess we are done. That's a lot.
In the documentation, there is some example to publish to Maven Centra.
Yes.
Yeah.
Yes. Where is it? Java packaging and publishing. So assemblies, Gradle, publish locally, publish soon attack central. Yeah.
And how does you need to sign the file? How can you do the same with Mill?
Mill asks you to provide a GPG key, and then not a GPG key, a GPG secret and passphrase.
Mm-hmm.
And then Mill will run GPG blah blah from the command line to do all the necessary signing. So yeah, you just need to give it these 4 environment variables: username, password, and GPG secret. We asked it base64 encoded because most CI systems only allow single strings as a secret, so you need to stuff in a single string, and the passphrase if you have one. And then Mill will you run one command here and it publishes Maven Central for you. Yeah. Yeah. Any other questions?
I'm curious about implementation detail because you can create the object graph
Yes.
without executing the code.
Yes.
How? How do you know that the resource task has a dependency with the code lines without executing?
Yeah, there's a compiler plugin that basically scans the body of the method to look for these method calls and then registers them. It's the same for the Java doc, which is normally not visible at runtime. There's a compiler plugin that grabs the Java doc and stuffs in a Java annotation that we use Java Reflect to pull out later. So it is a bit tricky, the implementation, and 1% of the time you need to do something special, you need to deal with this, but 99% of the time you can't just ignore it, it mostly just works. yeah, so it was quite tricky to implement. And things like capturing the file name line number as well, you have to also have to compile the plugin to put the file name and line number. So because when you use mil inspect at the command line, we need to capture the file name line number. How do we do that? Yeah, we put in annotation, you have to compile time, and use Java Reflect to fish out later runtime to print out to show you. So the implementation is quite complicated, but hopefully it doesn't bleed through to the user experience too much. Yeah, and I guess that's one of the reasons it's in Scala, because Scala is a bit easier to do these things, whereas to do it in Kotlin or Java is much more difficult. Yeah, like in Java you need to use like aspect J by code reading or something similar. Can be done, but more difficult than doing in Scala. Yeah. Any other questions?
Yeah.
Yeah.
So you mentioned at the very beginning, when you showed the example that mil was running in a loop and the very beginning was slow and then it was warm up. It's because the mil command line is, you said it's a Java application, right? And have you tried to make the mil CLI tool Gradle native image to avoid that thing and make it even faster?
Yes. So the answer to that is we do use native image. We can't use native image for a lot of things. So how mil works is that when I run /mil, it runs a command that spins up this background server, mil server main, that runs in the background. And the /mil command that spawns a server is a Gradle native image. But the background server has to be a JVM, and the reason for that is mil uses things like class loading and reflection, and native image doesn't support that easily. So, for example, mil needs to, when you change the configuration, mil needs to throw away the old class loader, recompile a new configuration at runtime, and load the new compiled class files into a new class loader and run that. So native image doesn't support all this kind of dynamism. So only the front end is a native image, which is why you see that mil version, for example, it's very, very fast, 0.1 seconds because it's native. But if I use the JVM launcher, which is also available, if I get rid of this native suffix, if I use a JVM launcher, you'll see it takes like twice as long to start because JVM takes time to boot up. Yeah, so we do use it where we can, but it's a lot of dynamism, so we can't use it for the main like code paths, only for the front end. Yeah. Thank you. Yeah. Any other questions?
Is there a migration tool from Maven if I want to try
There is a migration tool. It works like 70% of the way. So if you look at the docs, like why use mil? Migrating from Maven to mil. So you run mil init inside the Maven build, and it will load up the pom.xmls, and it will try and grab all the dependencies and internal external dependencies, JVM fork args, and it will spit out the mil build files that you see here on disk that you can then run using mil. This works 70% of the way. It will not know about your plugins. It will not know about your internal plugins, and doesn't know about most external plugins either. So you'll still need to kind of fiddle with it to get it to 100% later. But yeah, we have migration from Maven, from Gradle, and from SBT, which are the three big JVM build tools nowadays. I mean, they basically ask the build to dump out its metadata and just convert it to a mil file. Yeah.
Does this also work with Maven or Gradle multi-module projects, the migration tool?
Yes. So you look at this example. This is a Maven multi-module project with 3 modules. But yeah, it's pretty experimental, so you expect it not to work the first time because this tiny project works because it doesn't use any plugins. But the projects that have different plugins, especially internal plugins, the plugins won't be configured, and you have to figure out either customize it yourself, like I showed earlier, find a third-party plugin, or do without. In some cases, like assembly, you don't need a plugin in mil, for example. Yeah. At the back.
Yes. This tool just only works with Maven dependencies, or you can use another?
What other dependency repositories are you thinking of?
I'm not sure, but for example, if you want to use another repository from the Maven central repository.
As long as it follows the same format, it's okay.
Okay.
So you can pass in the Maven URL and point it at your own internal like mirror, for example. And if you need credentials, you can pass in credentials environment variable or as a home folder config file. Yeah, in theory, it works in IB2 repositories as well. I don't know if any of you have used IB. That's like many decades ago. And yeah, basically Maven and IB repositories, and you can publish to Maven or IB repositories as well. So Sonatype Central is the current one. OSS.sonatype.org is the old one they're deprecating next month. And then I think can publish to like Code Artifact and a few others. Let's take a look. Third-party plugin.
Okay.
Yeah, contrib plugins. So you can publish a bin tray, can publish a code artifact. These are plugins other people wrote for Mill. So I don't publish in these places, but someone needed to publish it, so they wrote it. Yeah, so it can publish to, and it can publish to GitLab. So I assume most places, as long as it follows the format, you just need to set up the HTTP credentials and make the API calls, and they'll do the publishing. Yeah, so maybe these are ones that are built in. Any other questions?
Glitch support?
I mean, there's me and there's the other 4 guys who work on this site, open source. If you want, you can email us and we'll help you. Yeah, you want to pay us money, that's fine too, but we don't charge money to help people on GitHub. This is an open source project. Yeah.
Apart from the examples we've seen today in the presentation, do you have any example on, with big projects, how much optimization did you get with that?
We don't have any bigger examples. I mean, the biggest example was Netty and Mockito, which are 50 and 20 sub-projects respectively. Yeah, the guys who have big Mill builds typically don't have big Maven builds at the same time. So, for example, the Chisel project, which is one of the hardware design companies, they recently migrated from SVT to Mill and they deleted their SVT build. So I don't know how it compares. We deleted the old one. So, yeah. I assume it will be somewhat proportional. I don't think that Netty and Mockito are unusual. They're like typical big projects. They're mostly standard, some customization. Yeah. Any other questions? Okay. Going once, going twice. I guess we're done then. Thank you. Thanks for listening. Sure, yeah. Yeah. Slideshow. Okay, perfect.
Okay, so news. We are finishing this season, but we still have one more talk. June 10th. We have, this is I think the 3rd year we collaborate with this Mess of the QA. It's kind of a month in June to have talks about Q&A, right? It's not about a meetup, it's not about technology, it's just any meetup, any community can contribute, and they organize a web page, they show there all the talks, and just Jonathan, he's from Barcelona, Jack, he's going to be here in Madrid in that day, and he wrote us an email and said, I'm going to be in Madrid, do you have time for a meetup for me? And we said, yeah, perfect. And he's going to talk about security flaws in Java and how to fix them. So I think that fits very good with this month of the QA. So June 10th, this is going to be the last meetup of this season, and we will come back in September because July and August is holidays and it's pretty hot here, and that's it. So we will open the meetup probably next week, and we hope to see you there. And pretty much that's it. There are new folks here, so we are not a legal entity here in Spain. Basically, we are just a bunch of people that talk about these things. So we have an open collective, and these 2 open collectives, one from Madrid and the other one from Madrid Group, allows us to get money from anyone and to spend money in paying meetup, paying maps, the stickers, whatever we need. And the nice thing about Open Collective is that all the expenses are there. So you can go to Open Collective and see how much time do we spend 3 weeks ago in the meetup renewal, right? Which was like $100 or something like that. So everything is there. You can support us if you want. And that's it. We have now, we are going to have the pizzas and the drinks now. Remember to keep the cycle open so anyone can join the conversation. And I think that's the last one. We are going to now stop the recording and we are going to have the raffle here for the people here. So that's it. Thank you.